Hi, Algebra 1. Welcome to the video for notes number 2, 1 and 2 step equations. We're still in Unit 1, and our learning target today is I can solve 1 and 2 step equations. So we have a key term first before we get started. Our key term for these notes is inverse operations. Inverse operations are operations that undo each other. We also call them our opposite operations. But inverse operations is the correct math term. So when we're thinking about our opposite operations, the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplying is dividing. And the opposite of dividing is multiplying. So we use our inverse operations when we're solving equations. We use our opposites to undo things. Some of the models that we use to represent equations are scales and mobiles. So if we look at the scale and the mobile, what they have in common is that they are balanced. They're the same on both sides. And this is kind of like where our equal sign comes in. Our equal sign tells us that our equation is the same, is equal on both sides. So if I had to turn this model into an equation, what I'm looking for is how many of these little red circles are in this envelope for x. What would have to be in here for this scale to be balanced? And the equation would look like my equal sign in the middle. On the left, I have the x, the part that I don't know, plus 3 of those red chips. And on the right, we have 7 red chips. When we look at the mobile, we have that same idea of things being the same on both sides. So when I write my equation, my equal sign goes in the middle. On the left, I have 31. What I am looking for is what number has to fit into this pentagon for my mobile to be balanced, to be equal on both sides. Because I don't know what the pentagon is, that's where I use my variable. So I'm going to call that x, and this side of the mobile would be represented by x plus 5. So when we're solving equations, what we are looking for is things to be equal and things to be balanced. So we are going to try the first 4 examples together, and then you will try the next 4 on your own. So in all of these problems, we are looking for our inverse operations. So when I start the problem, I'm going to draw my line through my equal sign so that I can see the 2 different sides of my equation or the 2 different sides of my scale. And then I'm going to ask myself, what is happening to x? In this first example, x is being added by 7. To solve this equation, I need to use my inverse operations. The inverse of adding 7, or the opposite of adding 7, is subtracting 7. To keep my scale balanced, I need to do the same thing on both sides, so I would take away 7 on both sides. Positive 7 and negative 7 is 0, so I don't need that anymore. And I end up with x equals 12 minus 7 is 5. To check my work, I go back to my original equation, and I need to make sure that this is balanced when x is equal to 5. So I'll substitute a 5 where the x is, and I need to make sure this is equal on both sides. Well, 5 plus 7 equals 12. And that's what the other side of my equation was, so my equation is balanced. Second one starts the same way. I'm going to draw my line through my equal sign. I'm going to ask myself what's happening to x. In this case, x is being subtracted by 5. The inverse of subtracting 5 is adding 5. Negative 5 and positive 5 is 0. So I'll bring down my x, bring down my equal sign. Negative 6 plus 5 is negative 1. To check my work, I go back to my original equation. Where my equation has x, I substitute the answer that I got. and I need to make sure this is balanced on both sides. -1 minus 5 is -6. So my equation is correct. It would be balanced when x equals -1. Next one starts with drawing my line through my equal sign. If I ask myself what's happening to x, in this example, x is being multiplied by 4. The opposite of multiplying by 4 is dividing by 4. 4 divided by 4 is 1. So I end up with x equals -12 divided by 4 is -3. To check our work, we go back to our original equation. I'm going to substitute a 3 where the x is. And in this case, 4 and x are right next to each other. I know that there's an invisible multiplication sign in between those. So when I substitute in 3, I'm going to put it in parentheses. And then I'll bring down the other side of my equation. Oh, sorry, I should have substituted a -3 here. Okay, 4 times -3 is -12. My equation is the same on both sides, so my answer is correct. And our last one. Start by drawing my line through my equal sign. Ask myself what is happening to x. In this case, x is being divided by 3. The opposite of dividing by 3 is multiplying by 3. So on both sides of my equation, I'm going to multiply by 3. When I multiply by 3 and divide by 3, that ends up being 1. So I end up with x equals 10 times 3 is 30. To check my work, I go back to my original equation. Where my original equation had x, I substitute my answer. So is 30 divided by 3 equal to 10? Yes, it is. My equation is balanced. It's the same on both sides. Okay, try the 4 practice problems underneath. Pause the video and then come back and check your answers when you're ready. Okay, for these 4, the answers are up here. And we are going to move on to looking at some two-step equations. When we solve a two-step equation, we are still using our inverse operations. And there is usually a pretty standard way that we solve a two-step equation. This doesn't happen all the time. There are some exceptions, but usually the first thing we'll do is add or subtract the constant on both sides. And the next thing that we'll do is multiply or divide on both sides of our equation by the coefficient of x. So we start with adding and subtracting, we finish with multiplying and dividing. We are going to look at a special case where this isn't true, but most of the time this is how this works. So on our first example, I'm going to start the same way I started my one step. I'm going to draw my line through my equal sign. I'm going to ask myself what is happening to x. In this example, x is being multiplied by 3 and added by 7. When I start using my inverse operations, I'm going to be going backwards. The inverse of adding 7 is subtracting 7. So I'll subtract 7 on both sides. Positive 7 and negative 7 is 0. So I end up with 3x equals 9. Now if I ask myself what's happening to x, x is being multiplied by 3. The opposite of that is dividing by 3. So x equals positive 3. I'm going to check my answer for this one, but I'm not going to check for the rest of them. The process is the same as it is for one-step equations. I go back to the original problem that I started with. To make sure that my answer is correct, I'm going to substitute the number that I got for x into my equation. So this would be, instead of 3x, 3 times 3, and I'm putting that 3 in parentheses, plus 7 equals 16. I need to make sure my equation is balanced on both sides. 3 times 3 is 9, so I have 9 plus 7 equals 16. And that is absolutely true. 9 plus 7 is 16. My equation is equal on both sides, so I'm all set. Okay, second example. Starting by drawing a line through my equal sign. Next, I'm asking myself what happens to x. In this problem, x is being divided by 3 and subtracted by 5. When I start doing my opposites, or my inverse operations, the inverse of subtracting 5 is adding 5. So now I have x divided by 3 equals 10 plus 5 is 15. I'm going to ask myself again what's happening to x. X is being divided by 3. The opposite is multiplying by 3. 3 divided by 3 is 1. So I end up with x equals 15 times 3 is 45. To check your work, it would be the same process as the other problems. Substitute 45 back into your equation. Make sure that it's balanced on both sides. Okay, our last problem here. This one is our special case. It doesn't follow the same order that our other problems did, where we add and subtract first and then multiply and divide. If I look at this problem and I ask myself what's happening to x, x is being subtracted by 7 and divided by 6. When I start solving, I need to go backwards and start using my opposite operations. The opposite of dividing by 6 is multiplying by 6. So on both sides of my equation, I'll multiply by 6. 6 divided by 6 is 1. So I end up with x minus 7 equals negative 9 times 6 is negative 54. Now if I ask myself what's happening to x, x is being subtracted by 7. The opposite of subtracting 7 is adding 7. Negative 7 and positive 7 is 0. So x equals negative 54 plus 7 is negative 47. Checking your work would be the same as before. I would substitute the negative 47 back in where x is, and make sure my equation is balanced on both sides. So I'm going to ask you to pause the video, try the next 3 problems, and then come back and check your answers. Okay, answers to the last 3 are up. The one that you might have questions about is probably the second one. On this problem, you have a couple of options. You can turn that fraction into a decimal. This one turns out really nicely as 0.5x. Another option is to make x part of the fraction. So we would have a fraction that looks like 1x over 2 plus 12 equals 6. And from here, you would be solving it either like the first example or the second example, depending on which method you're choosing.